Welcome to the lecture on phases of compiler. The objective of the lecture is to introduce the phases of compilation and then we try to relate them to language constructs. These language constructs you might have already studied in theory of computation. So this brief overview of phases of compiler was already discussed in the previous lecture. In this lecture, we'll go through each of the phase in compiler and try to explore its details. So lexical analysis is the first phase of compilation process, and this lexical analyzer is sometimes also called as scanner. Now why scanner? Because this is the only phase which gets to interact with the source program. So the source program here is nothing but our high level language program. Say for example, if there is a C compiler, then the source program would be a high level language program which is written in C language, and as soon as it gets into the compiler, it first goes to the lexical analyzer, also called as scanner, which scans the input from the C program. So hence it is also called as scanner. Now we'll also see why it is called as a lexical analyzer. So it is the interface of the compiler to the outside world, because this is the only phase which receives the input from the C program. So as soon as you get the source program, which is say for example in C or any high level language, the lexical analyzer's task is to give a stream of tokens. Now these tokens are basically representation of logically cohesive sequence of characters. So these sequence of tokens are also referred to as lexemes. Hence the name of the phase is lexical analysis. Now what a token can be for any specific language, it depends on the language which is considered. So some common examples of tokens are listed here. So keywords from the language can be the example of tokens. Operators, identifiers, symbols, constants, some string which you take as input. So all these are type of tokens. So basically these are the vocabulary of any language, right? So whenever you try to learn a new language, you are taught what are the keywords in this language, what operators you can use, what all are the rules to generate the name for a identifier. Identifier is nothing but a variable or a variable name which you give. Symbols, various symbols which are allowed, and there could be some constant numbers in the program, there could be some strings. Say printf statements have string inside, have some text inside double quote, so that is referred to as strings. So what does a lexical analyzer do? It scans the input source program, identifies the valid words from the language. So what could be those valid words? These can be any one of these which are listed. It also removes the extra white spaces. So while writing the program, you might give some extra blank spaces. You also provide certain comments. So all these things are not meaningful to the program, right? So all these are removed, and only the important words which are called as tokens or lexemes which belong to that language would be extracted. Okay, now generally a lexical analyzer is implemented as a finite automata. So just to remind you what a finite automata is, So you start from a starting state. This say start state is S0, and then if you get some input say A, you go and proceed to some other state, and this goes on until you reach say a final state. So that is basically a finite automaton, and to accept any token or to do tokenization, we need to implement a finite automata. Okay, so lexical analyzer, in just to sum up what a lexical analyzer does, it breaks up the source program into tokens. What are tokens? Tokens could be keyword, operator, identifier, anything. And how is it done? Now it does not know whether the incoming word, now everything is scanned a character by character. Say if I have in the program void, so it will first scan V, then O, then I, then D, and then comes up a space. Now after it encounters V, O, I, D, and then it gets to know a space is there, it knows okay, before space the word was void, and it then checks whether void can be part of anything, any token which is specified in the language. So it will say okay, yes, void, I recognize void is a reserved word, or maybe it can be simply called as a keyword because it has a reserved meaning in a language. So here void is used generally in C. Okay, so I'll quickly show you an example here. Okay, so if this is the input program given to the lexical analyzer, so you have written a small C program which prints the numbers from 1 to 10, and you give it to the lexical analyzer and just want to see what will be the output of it. So the output would be every single token is identified, and now something has to be done with these tokens. So we'll see what has to be done. So you can just pause the video for a moment and try to count how many tokens will be there and what these tokens will be. So void is 1, main is 1, opening bracket, closing bracket, curly bracket, int, count, semicolon, all these are different tokens. Okay, so less than equal to 10 is a separate token, semicolon is a separate token. So all these tokens would be identified, right? So this is the work of a lexical analyzer. Now after recognizing all these tokens, it stores this in a symbol table. So what it does in the symbol table would contain, we'll just talk about a few entries here. Later on we'll discuss the symbol table in detail. So what it does, it creates a tuple entry of the type token type and attribute value. So if we consider a statement, say int count is equal to 1 and then there is a semicolon. So taking the first word, so the token here is int, token type. So what type of token is int? It is basically a reserved word or a keyword. Now what will the symbol table entry be? The symbol table entry is token type. So our token type here is keyword, and the attribute value, the actual value of this token, which is int. Okay. Next word is count. So what is count? Count is not a reserved word. It is not an operator, not a constant. It is basically some variable which the programmer might have created. So this count is nothing but a variable. So we refer to the variable as an identifier. So what will be the symbol table entry? It would be identifier. I've used a small form of identifier as ID. So generally we'll be using ID to denote the identifier. And now here the symbol table entry was int because this int is already defined, but we haven't defined count yet, right? So count would be basically a variable which is allotted some place. So this will, the second entry here, the attribute value would be the pointer to that memory location. So this is a memory location where we have the count value. Okay, so we'll probably continue with this video as the second part in the next lecture.